Hi guys, thank you so much for coming. Make sure you put your phone in the holder if you just came in. Hi guys. Phones in the holder, please. So much. We have a few things to go over before I feel comfortable stamping. I like to stamp when I feel like I'm confident that I got a good chance to get everything done. So if you guys could all find this page for me in your packet. And notice something really important is missing on this page. It's the work. I didn't show my work. I just wrote the answers down. I was hoping that you could look at the answers and it would generate questions of which then I could go over the problems and show my work. But I want you guys to know these two are fine. This amount of work is not acceptable for a quiz or test, just so you know. That would not be an okay way to leave that problem. But okay, checking your answers. Are there any of these that you want me to go over? I have a couple in mind that I'm hoping you'll ask for. Maybe not D or G, because now that you read it, you're like, oh, I see. But maybe a couple of the other ones. Yes, Jules. Okay, so I was hoping for F for sure. C, okay. I love that you asked for C because they're both backward function machines. Backward function machines are definitely harder than forward ones. Okay. First question is for C and F. Do you recognize them as backward function machines? Okay, good. Okay, so we see that these two things are the same. So I'm going to take the 125 and I'm going to plug it in that spot where f of x is. So I'm going to take f of x and I'm going to replace it with 125. Okay, and you might have done that and still even got stuck. How do I undo a cubed, Landon?
Square root.
Almost. Cube root. Okay, so it looks like this. Cube root both sides. So undoing a cubed is a cube root. And this is great. We can go over this again. So when you have a cube root, you make 3 branches off of it because it's a cube root. And you have to think what times itself is 125. And the answer is 5. 5 times 5 times 5 is 125. So 5 equals x. Okay. Let's take that information to help us with F. So I'm going to take this and replace it with 99. So I have 99 equals x squared minus 1. How do you feel about the setup part? Like just equaling it. Is that okay? Okay. So now add 1. I'm sort of in the same spot here, but it's squared. How do I undo a squared? Square root. Square root. Okay, now this is the moment. I believe, which one of you two, you're not in trouble, which one of you two asked me about the plus or minus on the math test? Okay, I knew it was in this corner of the room. This, interestingly enough, just came up on your resource page. This symbol is plus or minus. It means that there's 2 answers to this problem, positive 10 and negative 10. How are you supposed to know when there's 2 answers? And the answer is whenever you square root both sides of an equation, there's 2 answers. Okay. When you square root an equation, two answers. When you square root an equation, there's going to be two answers. Not when you cube root, interestingly enough. It has to be an even root. I don't think you're going to fourth root anything in this class, so square root. Any other ones on number 36? And if you were completely stuck on 37, don't worry, I'm going to go over it right now. Jules, we good on those two? You probably saved half the class by asking those two. Okay, now scooch down to 37. Be honest and be brave. Does anyone leave 37 completely blank because you had no idea what to do? Anyone willing to admit it's okay? I had to help in Access with these. It's totally fine. It's the words. Like, you guys could do the math if you knew what they wanted, but it's really hard to tell what they want. Okay. Examine the function to find it right. Notice that g of 2 is 5. That is when the input x is 2, the output g of 2 is 5. I'm going to write this in a format that is easier for you. I'm going to write it in a coordinate 2, 5. These problems are asking for coordinates. This is saying, A, when the input is 1, what is the output? When the input is 1, what is the output? Okay, so I go to the little curve guy. And I say, it says find the coordinate where x is 1. Okay, do you guys all see that the origin is right here? Everybody see the origin? Okay, so I'm going to go over where x is 1, and I'm going to I'm going to make a dot to find the coordinate. So I went to where x is 1, and I found the coordinate. What's that coordinate? 1, 1, right? Do you guys see that the coordinate's 1, 1? Okay, so go back over here. The coordinate's 1, 1. So g of 1 is 1. Input, output. Input is x, output is y. Okay, likewise, what are g of -1 and g of 0? So I'm going to write -1 comma something, 0 comma something. Do you see what I'm saying? So I take this and make it into a coordinate, and it's saying -1 is the x, what is the y? 0 is the x, what is the y? Okay, so I scroll over, find the coordinates. All right, here's the origin. -1 is the x. Here is the coordinate. If 0 is the x, here's the coordinate. What is this coordinate? -1. Negative. It looks like -2 to me. -1, -2. So I go back over here. -2. 0 is -1. Is that helping for what is the problem's asking for? Now in C is hard. They're going to tell us to go backwards. It says, what is the input when the output is -2.5? So this is saying what, comma, -2.5. Okay, so we have to go a little different on our picture. We have to go, okay, we have to go y is -2.5. So -1, -2, -2.5. Here's the coordinate. What coordinate is that? -2.5, -3? Actually, I said that backwards, huh? -3, -2.5. By the way, if you have something a little different than -3, that's okay, because it was a curve and it's hard to estimate. Yours might be a little bit different from mine because It's kind of hard to see. But it should be somewhere around -3, -2-ish. Okay, everybody got that page done now. Okay, now can you get out the homework, which was 38 to 42. It's definitely done. I already saw it yesterday. Okay. Real quick, checking the answers of this. This is not the time to write this down. You didn't do it, you didn't do it. We're just checking answers very quickly. Everyone else said you all have your results on Monday. I actually sent them to the printer before school this morning, but the printer is jammed in there. It's so weird. No, Robert gets really, I'm sure there's a ticket for Robert. He doesn't want us to talk about it. And I'm really good at it. Oh, no, it's okay. It's okay. Okay, my time is next. Okay, so anyway, A is 8, B is 10, C is -2, D is no solution, because you can't square root a negative. Okay, and then 39, A is 2, B is 8. I feel like you guys all got that. And then C is really weird. You're supposed to put a T in the exponent, and it's just 2 to the T, and you can't do anything more with it. Which feels really weird, like you're leaving it undone, but that's it. Any questions about 38 or 39? Okay. 40 is this line, and C does not go through the line, so it's no. No, C is not on the line. You didn't really have to graph it. The graph wasn't required, but it's the easiest way to do it. Okay, 41, this is the fraction problem. A is -7/10. B, -8/3. C, 10/3. And D is -3. If you want to change these improper fractions to a mixed number, you can, but that's not required. I don't like to do it, it's extra work. I don't like extra work. I know. Anybody want to talk about any of those? Okay, and then lastly, number 40, where is it? Where, Mrs. Talbot, did you put, oh, wrong button clickings. Okay, here we go. And 42. Okay, so Mrs. Talbot, did we have to draw them? No, you didn't have to draw them, but I appreciate it if you did. A was 123 degrees, B is 123 degrees, and C is 57 degrees. Anybody want to talk about any of those? You guys know obtuse and acute, right? That's what you need to know for this. Yes, honey?
So nothing was labeled, even though it said to check the thing that was labeled. It didn't look to me like anything was labeled.
Like the little A, B, and C weren't there?
The A, B, and C were there, but nothing was like labeled to me.
What did you want to be labeled?
Oh, no, like
I was going to get the
bold,
book.
like boldly. Something like, that. I don't know.
There's another problem with these two where they label the lines that look like you have to answer the question for those, but you don't. So let's take a look real quick. Okay. So here's a, oh, are you saying that you feel like you should have had more than one of these?
No, well,
Or do you feel like you needed to find P, Q, and M also?
I don't, I didn't really care what they were saying.
I totally understand. Okay. All right. So, I see what you're saying. Determine the measures of the labeled angles.
Yeah.
And you didn't feel like the angles were labeled.
Yeah.
Understood. Okay. So when you see a lowercase letter inside of an angle, that's what they want you to find.
Okay.
This is an excellent question. P, Q, and M are the names of these lines.
Yeah.
P is like Perry for this line, and Q is like Quentin. That was as best I could do there. And M is like Marcus. Okay, so they wanted you to pretend this is like X, and this is like Y, and this is like Z. So you're gonna find X and find Y and find Z.
Okay.
Okay, so for me, what I do is the labeling is terrible on this. You're not wrong. I think it actually would have been better if they just would have left this off and just said, find the degrees of A, B, and C.
Yeah.
Would that have made more sense?
Yeah,
Okay.
That's what messed me up.
Okay, perfect. You're not the only one because some people asked me in Access about it also. Okay, anyway, so do you guys see how the 123 is a really big angle? And you see how A is a really big angle? So those are going to be the same. And B is also a really big angle, so those are going to be the same. But C is acute. Does that make sense that C is acute? So that's going to be 180 minus 123, which is 57. Okay, let me go here and cover this up. Perfect. Okay, so D is acute. So that's going to be, no, that's acute. So that's going to be, actually, this is not really proportionally correct, huh? Look at this. Did this mess you up? Did this mess anybody up? Do you guys see that they labeled 82 in an obtuse angle right here? That's CPM being fun for you. So that means that this guy has to be 180 minus 82, which is 98. And this guy has to be 98. And this guy also has to be 98. Okay, last one over here. Let me cover these up. That's 75. That's 75. That's 75. I feel like we need to send CPM a strongly worded email about how those look. That'd be fun for me. Okay. All right, so we've gone over the classwork. We went over the homework. Your map testing for most of you is done. Now can you find your warm-ups page, please? We are a little bit behind on warm-ups. Luckily, we're going to do 4 of them today. Luckily, they're all tiny. Nineteen's on the other side. I just put that there to remind myself that we need to do it. Okay. Okay, now number 13, super important. What does it mean when this stuff is all right next to each other? -2 and X and Y are all glued together. What operation is that? Multiply. Beautiful. Okay, so -2 times X is 4 times y is 4. -2 times 4 is -8 times 4 is -32. Okay, number 15. Why am I writing in blue, but I circled it in green? This is weird. Okay, anyway, number 15. This is a square root. You can tell it's a square root because it's plain. I'm going to make 2 branches off of it. What times itself is 144? Nice. You guys know your 12s? Just 12, 24, 36, 48, 60, 72, 84, 96, 108, 132, 144. No, 121, 132, 144. Skipped one. Okay. Cube root of 8. We're going to make 3 branches off of there like a little chicken foot. And we're going to think, what times itself is 8? Yes. 2. 2, 2, and 2. So the cube root of 8 is 2. Okay, now flip the paper over to find number 19. Because you guys found my reminder to myself. Classify each angle as acute, obtuse, right, or straight. This one is obtuse. Now you can see why it wasn't too bad to do 4 warm-ups, because they all took like 2 minutes. Okay, now I want to make anybody in the class feel better. If that last problem, number 42, was terrible, next week we're going to be doing those in our warm-ups. So we're going to be going over that again. So don't freak out. Nobody worry. We're going to go over the angle relationships again in our warm-ups next week. Okay, now if you guys could find this page right here that says 1-44 functions, and it's got some candy like wrong candy references. You'll notice in the CPM books, they're trying to not get sued. And so they take popular names of candies and sodas and things to change them a little bit. I think it's funny, so I like it. Oh yeah. Okay. So set that off to the side. We're not doing that immediately. And set this up right here in your notebook, please. Hey, everybody. This is one of my favorite CPM lessons of the year. I don't love them all, but this one I really, really like because I think it's funny. So let me find my theme. Too many buttons over here. Okay, number 43, the soda machine. The soda machine at your school offers several types of soda, except for that we don't allow soda on campus anymore. This is a really old book, but whatever. There are two, pretend they're healthy. There are two buttons for your favorite drink, Blast, while the other drinks, Slurp, Lemon Twister, and Diet Slurp, each have one button. Okay, so there's a picture of the machine over here. There's two buttons for Blast, one button for Slurp. I think I would be a Slurp fan if it were real. One button for Lemon Twister, and one button for Diet Slurp. Okay, so we all know that I'd have to drink Diet Slurp because I couldn't stand the sugar of regular Slurp if it was real, but you know. Okay. A, describe the input and output of the soda machine. Okay, let's pretend in a fantasy land first that we allowed soda on campus, but second, that it didn't need any money. It was free. Okay. What would the input of the soda machine be? What? Like on the machine itself. Okay, let me ask you this way. How would you tell the machine which one you wanted?
Pressing the button.
Pressing the button. Okay. And then what would the output be? Yes. There's a line. Two. Okay. Input, which button you press. Output, which soda came out. B. While buying a soda, Miss Whitney pushed the button for lemon twister and got a can of lemon twister. Later, she went back to the same machine, again pushing the lemon twister button, but this time she got a can of Blast. Is the machine functioning consistently? No. Why or why not? What happened?
Something random came.
Right, okay, so we're gonna write it in a very, yes, honey.
Or possibly ran out.
It could, but you're correct. Okay, no, and we're gonna say not functioning consistently. Okay, and then we're gonna make a little picture. So we're gonna say okay, let's pretend that this is the lemon twister button. She pushed the lemon twister button, and the first time she got a lemon twister. But the second time she got a Blast. Okay, see. When Brandy pushed the top button for blast, she received a can of blast. Her friend Miguel decided to be different and pushed the second button for blast. He too received a can of blast. Each of them asked 5 friends to push the 2 blast buttons and they all got the same result, a can of blast. Is the machine functioning consistently?
Yes.
Why or why not? Yes, they're getting blast every time. Okay, now should they be drinking 5 cans of blast? Probably not.
Only one student said yes. No. No need to apologize.
All right, last one of this page, and this is really, you got to think about this one. Not only do you need to think about the math part, but you also need to think about how to spell, how to pronounce this name, because I don't really know how to pronounce Lucy. Lucy. I don't know. Lucy. Lucy. Anyone? Any idea? Lucy? We're going with Lucy? Okay. When Lucy pushed the button for slurp, he received a can of lemon twister. Later, Taisha also pushed the slurp button and received a can of lemon twister. Still later, Taisha noticed that everyone else who pushed the slurp button received a lemon twister. Is the machine functioning consistently? Yes. Yes. The machine isn't the problem here. What do you guys think happens? They loaded the wrong things into the wrong spots, but there's not a problem with the machine. Somebody just put all of the lemon twisters into the slurp spot.
Oh my gosh.
But the
Why?
machine is okay. That's a really kind of a hard concept to think about. But what we're going to say is yes. Okay, once you guys are done with that, find your resource page, which is the 1-44 functions one. Okay, so we're going to inspect these tables and graphs on this page and decide if it is functioning properly. Okay, so this is a machine with candy in it. They hit button number 1 and they get a Sticks, which I'm thinking is a Twix. And they hit button number 1 and they get a Sticks. It's okay. They hit button number 2 and they get an M&Ms. They hit button number 4, they get an M&Ms. But then they hit button number 2 and they get a Duds. Is that a problem? What button number is malfunctioning? 2. When we have a table in math, where we want to indicate the problem is by circling it. So the circles on the table are going to be how you show your work. Okay, now we're gonna turn this to math. I want to try to see if there's any inputs that have two different outputs. So the first thing I'm gonna do is I'm just gonna look at this for any repeats. I just told him to, I'll stand it up Monday for late credit. Okay. For number 2 here, are any of the numbers repeating? Do you see any repeats? Okay, no repeats. Okay, so this is how you say it when it's not a soda or candy problem, it's an actual math problem. So the first thing you do is you look at the x's and you say, are there any repeats? And if there are no repeats, you say, yes, it's functioning, yes, it's functioning consistently. There are no repeating x's with different y's. Okay, let's examine the next one. Okay, number 3. Do you see any repeating x's? Yes. Okay, so I'm just gonna mark them. That's it, right? Just the 2's. Okay, now what I'm gonna do is I'm gonna check and see if the 2's have different outputs. Do they have different outputs? So then I say, there should be a space there. I don't know what's happening. Not a function. 2 has 2 different outputs, which are 9 and -8. Okay. A relationship between inputs and outputs is called a function. If the inputs and outputs behave like a soda machine that is functioning properly. Discuss with your team what it means for a relationship between inputs and outputs to be a function. No inputs have 2 different outputs. Okay, now scroll down to the bottom of the page where the table and graphs are in your mind. I mean, I have to scroll for real, but you guys don't really have to scroll for real. Okay. Examine each of the graphs and table below. Compare the inputs and outputs and decide if the relationship could be a function. Okay, do you guys see? We're going to start with number 3 because it's a table. I taught you guys how to do tables, but I have not really taught you how to do graphs yet. It's the same exact concept, but there's actually an easier way to look at a graph. So let's start with the table. So I say to myself, okay, I only look at the inputs. Do you see any repeats? Yes, okay. So -8 and -8. Those are suspect to me now. That the little arrows mean I need to check them. Okay, now, do they have different outputs? They're the same output. Because they're the same output, it's okay. It's functioning properly. If 11 was something different on the other one, it was something other than 11, it would not be a function. But because it's 11, it's functioning properly. Correct. You can have that whole table can be 11 on the output and it would be fine. Okay, so imagine they push -8, they got 11. They push -8, they got 11. That's okay. The problem comes in when you push -8 and you get 11, and you push -8 and you get 5. Then you would say not a function. Okay. That's a clarifying one. Move up to number, what? That's okay. Because remember, this is, I'm so glad you asked. Remember the soda machine? They had 2 blast buttons. Yeah, so button number 1 was for blast and button number 2 was for blast. It's totally okay if there's 2 different buttons that give you the same soda, but it can't be the same button gives you 2 different sodas. Okay, so that's why I gave you guys this process. I said, okay, just look for repeats here only. And then check those. Okay, next. Now, for graphs, it's the same concept. We're looking for any inputs that have repeating outputs, but there's an easier way to check on a graph, and it's called the vertical line test. On number 1, 2, and 4, we're going to do the vertical line test. Okay, what you're going to do is you're going to draw vertical lines on your graph. Technically, you should draw an infinite number of them. You guys know the difference between vertical and horizontal? No, you want to hit all the points. If it's the one with just coordinates, you want to hit all the coordinates with the vertical line. Okay, here's my question. Here's my question. Did any of my vertical lines hit 2 dots? So this one hit 1 dot, 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 and this one hit 1 dot. Okay, that means that there's no input that has 2 different outputs. So it is a function. And what we say is, yes, a function passes, I can write the word passes. I don't actually need a comma there either. Vertical line test. Yes, a function passes vertical line test. Okay, let's compare that to 2. We're going to look at this really cool snail shell deal, spiral guy. Did any of my vertical lines, do any of my vertical lines touch the spiral more than once?
Yeah.
Yes. That means that it's not a function. It means that some of the inputs have more than one output. Let me show you in a, let's just pick a spot here. Let's pick -2. So this line here has the point -2, 2. And this point here has the point -2, -2. See how it hit twice? Now it looks like a table that is not a function. Okay. Try that last one, number 4. Give it a go, give it a guess. Draw vertical lines on it. Where is he going? Why did he go that way and then this way? Okay. Did my vertical lines touch the curve more than once anywhere? No. That means we're good. This. Okay, so you see how this vertical line only touched it once? This vertical line only touched it once. This one touched it once. Okay. All right, we are almost done. You guys are done with your packet, so you can put your packet wherever you put your packet. All right, you guys, let's do number 45. It's super quick. And then we'll do the notes. We're so close. We're so close. Okay, 45. The important question. Is a vertical line a function? Is this a function? Okay, what would happen if I did the vertical line test on a vertical line? Okay, so I'm gonna get a different color. So I drew a red vertical line test over my vertical line. How many times did I hit the line? Everywhere, infinite number of times. It really, really fails the vertical line test. All right, you guys, last thing of the day. Tell me when you're ready. Give me a thumbs up and I'll scoot you down. Not everybody. Did you do it? I just want to know if they're done with this part. No? Mike, don't worry. Mike, wait. Orange parts. Okay, then put the orange parts in. I'll take it. He doesn't want to take a picture after this. He would like to leave, and I told him to take a picture of the rest of it, and he's very unhappy.
I'll take a picture. That's fine. I did dots for the people who turned police stuff because I don't know what your rate points are.
I'm so sorry.
Just the stage. Go.
All right, you guys, last little thing. So for the table, let's just practice this one more time. Only look at the X's. Do you see any repeats? You don't see any repeats? -6. Okay, so those are the ones we want to check. Do they have different outputs? Yes. Okay, so then we circle them. And we say, not a function. Shh. Please stop talking. -6. Why are you packing up? That is rude. I'm not done. Okay, so there's the work for that one. And then for a graph, it doesn't matter. You can just put one vertical line. If it fails the vertical line test, just put one where it would fail and mark it with the 2 coordinates where it would fail and say, not a function. Fails. Vertical line test. I wanted to give you 2 that failed because it's easier to see the ones that fail and then all of the other ones pass.